Alright guys, so welcome back for day 2 of lesson 9.3. Before we get started, the background noise that you're hearing is my daughter doing her gymnastics via Zoom. So we'll just have to hope that it's not too distracting. Alright, so today we're going to talk about exact values and horizontal distance. So the first thing we're going to do is evaluate the functions without the use of a calculator. Alright, and this is all going to be related to your unit circle. So when I get the x and y values, I'm getting them from here. Okay? So, first thing I'm going to do is just go through and write, is it x over r, y over r, y over x, r over x, y over, all that kind of stuff, okay? So we need to know the ratios. Tangent, for tangent, remember that that's y over x. For secant, well, secant is the reciprocal of cosine. And if cosine, remember cosine is x over r, so that means secant is r over x. Alright? The next one over here, sine. Sine is y over r. And then cotangent, well, cotangent is the reciprocal of tan. Remember, tan is over there, y over x. So cotangent is going to be x over y. Okay? The next thing you're going to do is, if you didn't already have it memorized, you can look at your unit circle, since you will obviously have the use of that for all of the assessments. All right, and you're going to look for 240 degrees, and you're going to grab the x and y values. Okay? So for 240, we're looking at, I'm going to write in here, negative 1/2 and negative root 3 over 2. Go to your unit circle, look for 11 pi over 6. I'll point to it here. Alright, so I'm going to write that coordinate down right here. So we have root 3 over 2, negative 1/2. Sine of negative 135, so find 135. Oh, actually, it's not 135. Let me see. We have to think of a reference angle for negative 135. Okay, so if we rotate negative 135, it's negative, so we're rotating the same direction that the clock rotates. All right, so you have to figure out where you would land. Okay, and negative 135 would be right here. Or you could add 360 to this, all right, until you get a positive coterminal angle. Okay, so we're going to use the coordinate negative root 2 over 2, negative root 2 over 2. Okay, and then finally, same thing, we're negative, so we have to rotate clockwise instead of counterclockwise. Alright, so you have to figure out what that's equivalent to, which is going to be 5 pi over 6. Alright, so we're going to be right there in our unit circle. So we're going to use the coordinate negative root 3 over 2 and 1/2. Alright, and because we're in the unit circle, remember our R value is 1. Our R value is 1. Okay, I don't need the R value for the other two. Alright, so here it's x over y, or excuse me, y over x. So we're going to have negative root 3 over 2 divided by negative 1/2. Okay, now we can't leave it like that because that's a complex fraction. So you may want to rewrite it as negative root 3 over 2 times the reciprocal, so it's negative 2 over 1. A negative times a negative is a positive. The 2's cross simplify, so you have a positive root 3. Alright, for number 2, you're going to have y over r. So it's going to be negative root 2 over 2 divided by 1, which is simply negative root 2 over 2. Okay. For this one, it's r over x. The r value is 1. The x value is root 3 over 2. So again, complex fraction, you might want to write that as 1 times the reciprocal of the second fraction, 2 over root 3. Alright, so now I have 2 over root 3, but I need to rationalize it, so I'm going to multiply top and bottom by root 3. So then I have 2 root 3 over 3. And the last one, x over y. So you're going to have negative root 3 over 2 divided by 1/2. You might want to write that out as negative root 3 over 2 times the reciprocal of that second fraction, so times 2 over 1. The 2's cross simplify, so you're left with negative root 3. Okay. Alright guys, so let me erase and get set up for the next problem we're going to work on. Okay. Alright, so horizontal distance. D in feet. Traveled by a projectile launched at an angle theta and with initial speed v, velocity in feet per second, is given by d equals v squared over 32 sine of 2 theta. Okay? So we're going to estimate the horizontal distance traveled by a golf ball that is hit at an angle of 40 degrees with an initial speed of 90 feet per second. Okay? So we have a golf ball given golf ball hit at 40 degrees with speed of 90 feet per second. Alright, so it's just a matter of plugging that information into the given formula. So the horizontal distance is equal to the initial speed, which is 90 feet per second, squared, over 32 times sine of 2 times theta, which is your degree of 40. Okay, so you're going to have 8,100 over 32 sine of 80. Alright, and then you would do your division and then times sine of 80, and you're going to get a distance of approximately 249.28 feet. Alright, so that was just a formula that can be used for horizontal distance. Alright guys, I just have a few quick reminders, then we'll be done this lesson. Or tricks and then reminders, I should say. Alright. So you might need to know or want to know or be asked something about the signs of the trig functions, like in which quadrant are they positive or negative. So I'm going to show you a trick for that. Okay, so for sine theta and its reciprocal, cosecant theta, they're positive in the first, positive in the second, negative in the third and fourth. For cosecant, or excuse me, cosine theta and secant theta, positive, negative, negative, positive, and then tan theta and cotangent theta, they're going to be positive, negative, positive, negative. Okay, so again, if you're asked or need to know where are trig functions positive, what I want you to remember is all students take calculus. And that's a mnemonic device, and I'll explain it. That's a mnemonic device to help you figure out where are the trig functions positive. Okay, so what you do is you use the first letter, all students take calculus. You put the A, all students take calculus. Okay? And then what you're going to see is that all of the trig functions are positive in the first quadrant. Tan and cotangent are positive, cosine and secant are positive, and sine and cosecant are positive. So all of them are positive in the first quadrant. In the second quadrant, sine only. Sine only. Now when I say sine only, it's sine and its reciprocal. So sine and cosecant are the only ones that are positive in the second quadrant. See, it's negative and negative for the other ones. In this quadrant, it's tan only. So again, when I say tan only, I'm talking tan and its reciprocal. So you can see in the third quadrant, tan and cotangent are positive, but the other ones are negative. And then finally, cosine only. So again, cosine and secant are positive, and the others are negative in the fourth quadrant. Okay? All right, and then that is really all, guys. Just remember, again, this is just a little reminder to help you with some homework. If you're trying to find the zeros of an equation, you're going to set the equation equal to 0 and solve. You might need to factor. You might need to use a quadratic formula, or you might need to use the rational roots theorem. So keep that in mind. And how do you graph polynomial functions? Remember, you plot the zeros, and then you think about the end behaviors of the functions to help you figure out which direction the ends go to get a sketch of the graph. Okay? Those are just some reminders in case that pops up in your homework. All right, that is it for lesson 9.3 day 2. Jump over and get your homework done. I'll see you back here for the next lesson.